We are going to discuss now finding arithmetic mean for the continuous series using three different methods: direct method, shortcut method, and step deviation method. But before we do that, let's take a look at what is a continuous series. So a continuous series is a type of data set where we have the data set X. That is, you have class intervals 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60. So we do not know the exact value, but we know that it was between the class interval of between the lower limit of 0 and upper limit of 10, or between the lower limit of 10 and upper limit of 20. So the lower limit is included in the class interval and the upper limit is not included in the class interval. That means 10, a student who scores 10 will fall in the second class interval and not the first class interval. Now 8 students have scored between 0 and 10, but we do not know what their exact scores are. Similarly, 30 students have scored between 30 and 40, but we again do not know what their exact scores are. So when we do not know their exact scores, we do not have a x value. So we need to find a substitute for the x value in our formula, and we use the mid value or m, which is derived by finding the mid value between the upper limit and the lower limit of each class interval. And how do we do that? We take the upper limit, add it to the lower limit, and divide it by 2. So for the first class interval 0 to 10, we take 0 plus 10 and divide by 2 to get 5. Similarly, the mid value between 10 and 20, add 10 plus 20 and divide by 2 to get 15. Similarly, 20 to 30, add 20 plus 30, divide by 2 to get 25. So on. We'll find the mid value for each class interval. Then we add up the number of students, that is, we add up the frequency for each class interval to get a total n or sigma f of summation f of 105. The last step before we calculate the arithmetic mean is to calculate the frequency into the mid value for each class interval. So we take the mid value 5, multiply it with the frequency 8 to get 40. Similarly, I take the mid value 25, multiply it with 20 to get the f into m value 500. Similarly, 25 into the mid value 45 gives me total f into m of 1125. So once we have found the frequency into the mid value for each class interval, we then add all these values to get a sum total of f into m of 3525. This is the value which we will end up using in our problem. Now, once we have found that, we insert this value into the formula. X bar is equal to f into m divided by n. So we substitute 3525 for sigma fm. N we substitute 105. We get the value once we using a calculator 33.57. Now, the second method is called assumed mean method. Just like the discrete series, the assumed method is very similar, but instead of x, we find the deviation value dm for the mid value. So here we subtract a, which is one of the assumed middle values. So here we take 35 as our mid value and we subtract it from all the mid values. So 5 minus 35 gives me minus 30. 15 minus 35 gives me minus 20. 25 minus 35 gives me minus 10. So like that, I find the deviations from all the mid values. And then I multiply these deviations with the frequency. So minus 30 into 8 gives me minus 240. 10 into minus 20 gives me minus 200. 20 into minus 10 again minus 200. 30 into 0 gives me 0. 25 into 10, 250. 12 into 10, 240. Now once I have calculated all of these, I just need to find the sigma or the summation of all the frequency into the deviation values, and doing that I get sigma f into dm is equal to minus 150. So why is this method simpler? Because now I can just eliminate. So I can eliminate 240 minus 200, 250 gives me 50 remaining. 50 and minus 200 gives me minus 150. So in that way, it becomes much simpler to calculate the sigma f into dm. Now once I've done that, I go to the formula x bar equal to A plus sigma FDM divided by N. And I substitute the value. So my A is equal to 35. My sigma FDM is equal to minus 50. My N value is 105. Now this 150 into divided by 105 gives me 1.43. 35 minus 1.43 gives me 33.57. So my mean is 33.57. The next method is called step deviation method. Now in the previous shortcut formula, we took assumed mean A and subtracted from all the mid values. Here we not only subtract A, but we also divide it by the value I. So please take a look. I is the class length, and how it is derived, I take the upper limit of the class interval, subtract the lower limit of the class interval 0 to get 10 minus 0, which is equal to 10. So my class length or I is equal to 10. Now once I have found that, I can use the formula. Let me just go back. So I can use the formula d dash m is equal to m minus a divided by I, where I is equal to 10 and a is equal to 35. So for the first class interval, let's just take a look. It is the mid value is 5. I subtract the a value 35 and divide by 10. So 5 minus 35 is minus 30 divided by 10 is equal to minus 3. So this makes the calculation much more easier now. When I take the frequency and multiply with the d dash m value, it is 24. So calculation is made easier in this method. That's why we use the step deviation method wherever calculations are a little harder. So here now, once I have done that, I calculate d dash m value for all the mid values. So 15 minus 35 divided by 10, 25 minus 35 divided by 10, 35 minus 35 divided by 10, 45 minus 35 divided by 10, and 55 minus 35 divided by 10. That gives me minus 3, minus 2, minus 1, 0, 1, and 2. Next, I multiply them with the frequencies. So I multiply 8 into minus 3 to get minus 24. I multiply 20 into minus 1 to get minus 20. I multiply 30 into 0 to get 0. 25 into 1 to get 25. And 12 into 2 to get 24. Now in the last column, in the last row, I get the summation values of f d dash m is equal to minus 15. Similarly, the frequency summation is 105. So now this actually is easier to calculate because I can very easily cancel out here. So 24 I can cancel out. Minus 20 and 25, 5 remaining. And then 5 and minus 20, minus 15. So in this way, calculation is much more easier in this particular method. Now we will go to the formula and we'll insert the values to solve the problem. So now a plus fd dash m divided by n into I is my formula here for the step deviation method, where a is equal to 35. Sigma fd dash m we have calculated as minus 15 divided by n of 105 multiplied by I of 10. So this gives me within the bracket minus 15 divided by 105 is equal to 0.143. The negative sign I have taken outside and multiplied with the plus sign to get minus. So 0.143 into 10 gives me 1.43. So 35 minus 1.43 is 33.57, which gives me a mean of 33.57. Now if you have understood all these methods, pause your video now, note down these two problems given below and solve them using all the three methods. For the first problem, it is very easy. You have a very simple class interval problem. So you just take the class intervals and calculate the mid values, and then you can use the three methods. For the 23rd problem, or the second problem here, you have the format where you are given below 20, below 30, below 40. So if you remember, we had used this in the first chapter. So below 20 becomes 10 to 20, below 30 becomes 20 to 30, below 40 becomes 30 to 40, and you have cumulative frequencies here. So you have to calculate the actual frequencies. So for example, let me use the pen here to show you. So frequencies, if I calculate for the first class interval, it will be just 10. For the second class interval, it will be 18 minus 10 is equal to 8. Third class interval, 25 minus 18 is equal to 7. So subtract the previous frequency from the current cumulative frequency. So 32 minus 25 gives me 7 again. 43 minus 32 gives me 11. So do this for all the class intervals. Construct the class intervals 10 to 20, 20 to 30 and so on. Then you use the three methods to solve the mean.